And pwede mo ma-enlarge at saka ano, yung kamay ba lang ang mag-control?
Touchscreen man ito, Doc, no?
Yes, touchscreen.
Okay, sige.
So that's why nandito na ako ngayon sa beginning. For example, this is the alveolus. Ito. Visible ba itong kamay, itong pointer?
Yes.
So, nandito na tayo sa alveolus. Inside the alveolus, the PO2, the pressure of oxygen, is 104 millimeters of mercury. And then that of carbon dioxide is 40, okay? That's in the alveolus. And then the expired air, you notice that the PO2 is 120, while the PCO2 is 27. Why is this? Because in the expired air, in the dead space, there are still plenty of oxygen from the outside going to the inside. Since there is no exchange of gases in the dead space, so the amount of oxygen there will remain. So that's why the expired air has higher oxygen level, 120. Okay, so that will go out. Whereas your carbon dioxide from 40 here in the alveolar area, once it finds its way into the dead space going to the outside, now this will become 27. Why? Because this will be diluted. There is dilution. Because this is humidified air, remember? So that's why it's only 27 millimeters of mercury. Okay, while the inspired air, you notice here, the PO2 is 160 millimeters of mercury, whereas your PCO2 is only 0.3. So very low level. That's why in your expired air, your 0.3 cannot really dilute much of your 40. It is more of the water that will dilute the 40 millimeters of mercury to 27. Okay? But your inspired air, once it reaches, because this is humidified and diluted, right? So when it reaches the alveolar area, it is only 104 millimeters of mercury. And of course, in the alveolus, it's 40, the PCO2. Okay? Now, for example, the person has inspired air. So from the alveolus, the oxygen will find its way into the pulmonary capillary. Okay, so in the inspired air, the PO2 is 104. And then you notice that in the capillary, the PO2 is only 40 because this comes from, this is your pulmonary artery, and your pulmonary artery carries with it unoxygenated blood because it comes from the cells, okay, from the tissues. So no more, the oxygen has already dropped. And your PCO2 is high. Why? Because product of metabolism is carbon dioxide, okay? And so it is carried towards the lungs. So 45 millimeters of mercury when it arrives in the alveolar area. Remember, The alveolus and the capillary, they lie side by side with each other. And there are so many capillaries in the lungs that when you, because the surface area is so big, when you spread it, it covers one tennis court, okay? That is how big is the surface area. So the exchange of carbon dioxide and oxygen happens in the capillary of the pulmonary artery, okay? So your, excuse me. Dali lang, G. Okay, 45. So when it finds its way into the alveolar area, now this will become only 40. Okay. Now, in the pulmonary vein, capillary vein, the alveolus carries plenty of oxygen. And so, naturally, since by law of diffusion, your oxygen is higher, so it will go into the vein. And your CO2, since it is higher in the pulmonary capillary artery, it will diffuse towards the alveolus, and the oxygen will diffuse towards the capillary. Okay, so now your 104 millimeters of mercury will go into the systemic circulation. You notice that in the systemic circulation, your PO2 is only 95 millimeters of mercury. Why is this? Because of the diluted, remember there is blood that supplies the bronchus and the bronchial tissues, bronchial part of the lungs. And this unoxygenated blood will supply the bronchus, bronchi, terminal respiratory, terminal bronchioles, like that. And this will not go back. This is from the aorta, and this will not go back into the aorta. This will find its way into the right, into the left atrium, okay? And so this, and towards the left ventricle, and then back to the aorta. So your 104 is now diluted with unoxygenated blood. That's why it's only 95 millimeters of mercury. And so therefore the same. And this will find its way into the tissues, okay? The oxygen moves into the tissues and the carbon dioxide will move out, okay? Now, once it reaches the cells, the tissue capillary oxygen is 95 millimeters mercury. This will go out into the interstitial fluid between the cells and the capillary, okay? And what happens? The 95 millimeters of mercury, once it reaches the interstitial fluid, it is diluted. with the interstitial fluid. So now it will just become 40 millimeters of mercury. And when it enters the tissue cells, this will become diluted farther and now will become only 20 millimeters of mercury. But actually the mitochondria will only utilize 5 millimeters of mercury per cell. Okay? So what happens, what will the body do to compensate? That's why the cells are aplenty. These trillions, 300 trillions, okay, of cells, so that the amount of energy, ATP, that will be produced from the 5 millimeters of mercury oxygen is enough for the body to move, okay, to do its activities. Now, from the cells, from the tissue cells, can you hear the knocking? Because our neighbor is a shop, machine shop. Okay. Sorry for the interruption. Sometimes we have to remind our neighbors. That is what I said. When you are in medicine, you will become physicians, right? Temper doesn't have a place in medicine. That means no to anger. Your patience, not patient, huh? Patience has to be stretched so far as possible. Ganun yun. Just like the behavior last time when you had your quiz, somebody shouted because I talked, right? That temper doesn't have a place in medicine. You have to change that. That is a negative activity on your part. And you know, that is a negative action, and that you put it out from your mouth, from your body, and so that thing will cater in negative energy back towards you. And what is the effect of negative? That will harm you, okay? So try as much as possible to be positive. You control your temper. You control, you master your emotions. Okay? That is already a very concrete example of a negative activity on your part. If you do that to your patients, what happens to your patients? Mamatay inyong pasyente. Huh? Because that is negative. You are throwing negative energy to your patients. That positive. Always, although the most negative term in 2020 is positive. That means positive sa COVID. The most negative term in 2020 is positive. Because when you say it implies positive with COVID, okay? But in our case, positive is really positive. Okay? Yeah, ganun talaga yun. Because you will become physicians. You will be handling life. No life is for sale in the mall, in the mercado, in the market, in the stores, in the sari-sari stores, wherever you go, no life is for sale. Okay, that's why it is very important that you take care of the life of a person. And eventually, you will be in charge. You'll be taking care of the life of an individual. Because you will become physicians, right? Yeah. And if your attitude is always negative, you always criticize, you find fault finder, like that. You don't appreciate what you have, what your assets you have. That is not being grateful also. The attitude of gratefulness, generosity, and humility. That attitude of getting angry, there is no humility in that. Okay? So better, while in the first year, better change your attitude, because your attitude helps you reach the altitude. You cannot reach the altitude if your attitude is always negative. You have to be positive all the time, especially if your patient is dying and you cannot do anything anymore because it is already his or her time to go. It is the schedule to go. So no matter how many doctors there are surrounding the patient, no matter how sophisticated is your machinery, your apparatus, because it is already his time, her time to go, then all odds will be against you. You know, just there is a malfunction of this, like that. If it is already your time. And so it is at the point in time, it is so difficult to be positive, to have a positive attitude. Because you're dying and you don't want the patient to die. Kung pwede lang hilain, no? Pabalik yung patient. Because that will also reflect on your reputation as a physician. And so While in the first year, you have to control your emotions. You have to handle them very well. Be positive. Okay? Because with my neighbor knocking on his machine shop, dapat nagalit na ako, right? Because it is interrupting my lecture. But hindi yan pwede sa akin. So I told my neighbor, excuse me, can I request something? Pwede ba mahina yung knock kasi may klase ako? See? And they said, very well. Kaagad. And no emotions hurt. Okay? Ganon yun. Because you will become physicians. No place, temper doesn't have a place in medicine. Remember that. Okay? Whoever did that, don't want to know the name. And have forgiven you. Just don't do it again, because that kind of attitude is negative. If that is always your attitude, you will not become a good physician. If you are bright in class, you might become a physician, but since your attitude is negative, then that will reflect on your patients. That negative attitude, that is the one that will throw to your patient. And it will come back to you 1,000-fold. You see, ganun yun. That's the law of, yun, nasa neuroscience yan eh. Try to study neuroscience. Okay, your PO2 from the tissue cells is already, because this is the amount of carbon dioxide that the cells will produce. And this 45 will travel towards the heart and towards the lungs, right atrium to the right ventricle and towards the heart. Okay? And so now, so yun na. And this carbon dioxide will go through the interstitial space to the blood. It will find its way to the plasma and then towards the hemoglobin. And this is being transported into the systemic circulation. And it will find its way into the right atrium and towards the right ventricle, then coronary arteries. Okay. Okay, now I'm sorry, my internet. Oh, I am just reminded of your reporting because you said that you would like to pray record. Am I correct? Miss Joanne? You would like to pre-record the reporting so that when you present it,
Doc, some ask,
tuloy-tuloy.
yes,
Okay?
some ask if pwede pre-recorded daw yung
Yes.
ano,
Because,
yung report.
huh?
Some ask po if pwede daw pre-recorded yung report just in case po maano po sila ma-disconnect.
Yes, yes. Kasi na-reminded lang ako ngayon. I'm reminded because my internet now is low. My computer says internet connection is low. So probably there is a possibility, big possibility that it will happen during the time when you'll be reporting, especially now that there is a low pressure area. So mas maganda siguro i-pre-record, right? Yeah. So that smooth presentation. You choose your member who has the best communication skills, okay? So that the presentation is very good to listen. The voice, the diction, the enunciation matters. Yeah. So, ganun na lang. Probably it's better if it is pre-recorded. Okay. So it is pre-recorded. It is agreed, okay?
Okay po, Doc. Thank you. Thank you po.
Okay, welcome. Now, you have already discussed about hemoglobin, right? In biochemistry, right?
Yes, Doc.
Can I hear an answer?
Yes, yes, Doc.
Yes, Doc.
Yes, Doc.
Yes po, Doc.
Yeah, and this is just a review. So I will not go into details because it has been discussed in biochemistry. So your hemoglobin is a globular protein of 4 subunits. Each subunit is a porphyrin ring with iron in the ferrous form. Your heme moiety, okay? Each subunit has a polypeptide chain of 2 subunits. Alpha, 2 subunits have alpha and 2 have beta chains because you have 4 subunits, okay? So 2 of that is alpha and 2 is beta in adult hemoglobin. So your adult hemoglobin is called alpha 2, beta 2 hemoglobin. So right shift. We will discuss about right shift later on. Your fetal hemoglobin is alpha 2 and gamma 2. So it has the 2,3-diphosphoglycerate binds less avidly to the alpha chain, gamma chain. So this is left shift. Kakapit siya instead of bibitawan, okay? While the adult hemoglobin, this will release, okay? Your methemoglobin, the iron is in the ferric state instead of ferrous, so does not bind oxygen. Hemoglobin S is the alpha chains are normal, but the beta chains are abnormal. And these are the ones that are found with sickle cell anemia, and usually in the black race. Okay. Oxygen binding capacity of hemoglobin means the maximum amount of oxygen that can be bound to the hemoglobin. This limits the amount of oxygen that can be carried, and because it has a limited oxygen binding capacity, so it follows that the amount of oxygen that will be carried is limited also. So when there is full binding of the 4 subunits of the, so there is 100% saturation. It is expressed in units of ml oxygen per gram of hemoglobin. Hemoglobin combines rapidly and reversibly with oxygen to form your oxyhemoglobin. The hemoglobin oxygen dissociation curve is a plot of percent saturation of hemoglobin as a function of your PO2. So oxygen content of the blood. This is the total amount of oxygen carried in the blood, including the bound and dissolved oxygen. Because from the alveolus, the oxygen will pass through the respiratory membrane, the basement membrane of the alveolus, and then the interstitial fluid, and then it will go to the basement membrane of the capillary that lies beside that alveolus. Okay, so the total amount of oxygen carried in the blood, including bound and dissolved oxygen, is the oxygen content of the blood. And it depends on the hemoglobin concentration. The oxygen binding capacity of hemoglobin and the P50 of hemoglobin. I will tell you about your P50 later. So the oxygen content equals hemoglobin concentration times oxygen binding capacity times percent saturation plus dissolved oxygen, where oxygen content equals the amount of oxygen in the blood, ml oxygen per 100 ml blood. Hemoglobin concentration is the hemoglobin concentration in grams per 100 ml. The oxygen binding capacity is the maximal amount of oxygen bound to hemoglobin at 100% saturation. So this is ml oxygen per gram hemoglobin. So percent saturation is the percentage of heme groups bound to hemoglobin, to oxygen. Okay, that means the hemoglobin that is being bound with oxygen, that is your percent saturation. It will reach a certain saturation point if the 4 chains are bound already with oxygen. And aside from the oxygen that will bind to the hemoglobin, there are also oxygen molecules that dissolves directly to the blood plasma. So this is unbound oxygen and ml oxygen per 100 ml blood. Hemoglobin combines rapidly and reversibly with oxygen to form your oxyhemoglobin. So you have your oxygen dissociation curve. Is a plot of oxygen saturation. Of hemoglobin as a function of your PO2, partial pressure of oxygen. At a PO2 of 100 millimeters mercury, hemoglobin is 100% saturated. So that means oxygen is bound to all 4 heme groups. Your 2 alpha and your 2 beta is bound with oxygen. So full, yeah, 100% saturated. At a PO2 of 40 millimeters of mercury, that is a PO2 of 100, okay, millimeters of mercury. That is arterial blood. At a PO2 of 40 only millimeters of mercury, this is mixed venous blood. Hemoglobin is 75% saturated, which means an average of 3. Out of the 4 heme, only 3 is bound with oxygen. So that is 75%. At a PO2 of 25 millimeters mercury, hemoglobin is only 50%. That means only 2 chains are bound with oxygen. So that is your P50, 50% saturation. Yeah. Now, we will look at the transport of oxygen and carbon dioxide from the alveolus towards the tissue cells, and from the trip of the oxygen from the alveolus to the tissue cell, and the journey of the CO2 back to the lungs, okay, to the alveolar area. This is the normal. Arterial end, remember, it is only, the PO2 is only 40 millimeters of mercury. At its end, the PO2 is already 104 millimeters of mercury. So if this is your blood PO2, this is your uptake. You notice the red line here? Can you hear me? My internet is slow.
Yes, Doc.
We can hear you.
Yes po, Doc.
Yeah. Thank you. Your blood PO2, if it is you notice that from 40 up to around 90 plus, the binding of oxygen is quite fast, okay? You notice that here, huh? That's why the line is quite steep. Once it reaches 97 or 98, you notice that the binding of oxygen to the hemoglobin is slow and it reaches a saturation point, okay? Now, you notice that in the capillary, on the first 1/3 part of the capillary, you notice that the line is quite steep, okay? So the binding of oxygen towards the hemoglobin is very fast so that it can reach saturation point of 90 very fast, okay? This is normal. This is for emergency. Because 40 level, this is not compatible with life already. If the saturation of your hemoglobin, if it is only P50, it is not compatible with life. So you notice that the oxygen has to bind plenty of hemoglobin. That's why the patient is given oxygen, okay? And the reaction of the body during the first 1/3 of the capillary, plenty of oxygen will bind to hemoglobin. Thus, when it reaches around 70 or 75, the patient can already breathe, okay? And so, usually the consciousness will come back. Thus, this is a safety factor. 1/3 of your capillary. The time, you notice these are still slides of Dr. Gogo, the former chairman. He's now in the US. Nag-migrate after Yolanda. Now, during exercise, the time that the blood remains in the pulmonary capillary may be reduced to less than 1/2 the normal. This is not a problem because the diffusing capacity of oxygen increases almost 3 times during exercise. In non-exercising conditions, the blood becomes almost saturated with oxygen by the time it has passed through 1/3 of the pulmonary capillary. So this is allowance for exercise. This one. This is a safety factor. Okay. So arterial blood has lower PO2 than pulmonary capillary and pulmonary veins. Why? From the capillary of the pulmonary capillary, the blood goes to the oxygen will go to the systemic circulation, okay? To the right, to the left atrium, and then to the left ventricle towards the aorta and then to the systemic circulation. Okay, then towards the tissues, from the tissues to the individual cells. Okay, so from 40, okay, from a level of 40, bakit ganun? The pulmonary capillaries will be filled up with oxygen and then mixed with pulmonary shunt blood from these are the blood from the bronchial area. So continuation of that is the lowered systemic arterial blood oxygen. The effect of venous admixture, a combination of fully oxygenated blood and the venous blood. So this will become 98% of that enters the left atrium, pass through the alveolar capillaries with a PO2 of 104 millimeters mercury. 2% of the blood passed from the aorta through the bronchial circulation, which supplies the deep tissues of the lungs. Okay, and so when it is mixed, so now this one here, this will lower, okay? There is an admixture. And so when it reaches the systemic capillaries, the amount of oxygen will be lowered because this is being distributed towards the cells, okay? And so now it will slowly, the level slowly go down until it reaches back to your 40 millimeters of mercury PO2. That is the journey of your oxygen. So diffusion of oxygen from a tissue capillary to the cells. Upon reaching the semiculation admixture, there's only a 95 millimeters of mercury level. Upon reaching the tissue capillaries, the oxygen will be diluted. Once it reaches, it goes out of the capillary towards the interstitial space. This will be diluted. More diluted when it enters the red blood cell. So it will now only become 23 millimeters of mercury. And out of the 23, the mitochondria will only utilize 5. So ito ang sinabi nilang better have an excess supply than lacking, okay? Diba? Mas mabuti ang extra, with extra supply than kulang. Okay? So, in the venous end of the capillary, the pressure of your oxygen is now only 40 millimeters of mercury. And it is this pressure that will go back into the lungs. Okay. Effect of blood flow and rate of oxygen consumption and tissue PO2. So this is your normal. Blood flow percent of normal, okay? This is your interstitial fluid, PO2. When there is exercise, when there is increased rate of blood flow, it increases the interstitial fluid PO2. So there is an increase and the rate of tissue, because the individual is having an exercise. So the amount of oxygen that will be consumed is 4 times normal when there is exercise. So the blood flow also will have to go faster. Okay. Blood flow will have to go faster. Okay. So the consumption is faster. So the amount of oxygen will decrease. If the consumption is less, the amount of oxygen will also go higher. Okay? So the amount of oxygen in the interstitial fluid will also increase because the consumption is very slow. Okay, diffusion of carbon dioxide from the peripheral tissue into the capillaries. So that is the story of oxygen. How about carbon dioxide? In the arterial end of the capillary, PCO2 is 40 millimeters of mercury. But inside the cell, carbon dioxide is 46 millimeters of mercury. And in the interstitial space, PCO2 is 45 millimeters of mercury. Why? Because this is being diluted. And then this is the one that is being brought back towards the lungs. Then this will find its way into the venous side of the capillary. So of mercury pressure is the one is pressure that will reach the alveolar area. So this is the pressure that when the blood leaves the tissues. So this will find its way into the lungs, alveolar area. So this one here, this is your alveolar carbon dioxide partial pressure against your blood PCO2. Okay. About 45 millimeters of mercury when it reaches the alveolar area. But it is the artery that carries the blood towards the lungs, pulmonary artery, capillary, okay? So 45. Upon reaching the alveolar area, the 45 millimeters of mercury carbon dioxide will diffuse towards the alveolus. Why? Because the pressure here is higher than the one in the alveolar area. Alveolar area is only 40, okay? So upon reaching the venous end, this will become 40 na lang. Okay? So only 5 is being taken. And you notice that 45 very fast is the taking up of carbon dioxide into the alveolar area. You see? And Yun na nga. And this is the one, this is the pressure that travels towards the systemic circulation and back towards the tissue cells. So a decrease in blood flow towards the alveolar area increases the peripheral tissue PCO2. Okay, why? Because the carbon dioxide could not go into the alveolar area because there is a decrease in blood flow. Increase in tissue metabolic rate also increases the interstitial fluid PCO2 and vice versa. Okay? So you notice here, if the blood flow, this is the normal. This is solid red line. When the metabolism from 45 from 40, this will become the PCO2 will become lower with increased blood flow, okay? So you notice that 10 times normal metabolism, more CO2 is produced. So the PCO2 is increased with increased blood flow. 100, 200 to 300% of normal. If the blood flow is very low, so the metabolism is decreased, so very low amount of CO2 is produced. Okay, because metabolism is decreased. Okay. Here is your oxygen hemoglobin dissociation curve. It's not a straight line because the saturation of oxygen will reach 100%, remember? So 97% of the oxygen transported from the lungs to the tissues is carried in combination with hemoglobin and the red blood cells, okay? 3% is transported in the plasma, in the dissolved state, in the water of the plasma and blood cells, okay? So that is 100%. Now, this is the pressure of oxygen, your PO2. Now this is reduced blood returning from the tissues. This is your hemoglobin saturation, 100% to 0, okay? If there is no oxygen that will combine with your hemoglobin, so there is no oxygen. PO2 is also 0, okay? But this is not compatible with life. And so you notice that the oxygen will really combine fast during the first 1/3 of the pulmonary capillary, okay? This will combine very fast. Now you notice that with a pressure of, partial pressure of PO2 40, you will notice that it is already 70% saturated here, okay? So more or less, this is already compatible with life, even with a pressure of 40. Why? This is for emergency. Emergency. Okay? So even with a hemoglobin pressure, oxygen pressure of 40 in the blood, the hemoglobin is already 75% saturated. So this will rescue the patient. So the more, if the PO2 will increase to 50, 60, 70, okay, up to 100. So what do you notice? It is already around 97% saturated. You see, that is to rescue the patient. That's why you have to give oxygen right away when the patient arrives at the emergency room. And then you have to clip. You notice the finger with the saturation, with the meter for the hemoglobin saturation of oxygen. Okay, yeah, the normal is around 98. And so that's why if you are a COVID patient and you are at home, try to purchase this this saturation, this apparatus that is being clipped on the finger to measure the oxygen saturation of your hemoglobin. If you are managing yourself, for example, you are positive with COVID, and if that saturation will lower, you have to exercise so that the oxygen will combine with your hemoglobin, and so it will reach up to the lungs. There is oxygenation to the tissues. Okay, it can get oxygen from the lungs. This is what one of the nurses did in the US, Filipino nurse, during the time when the COVID started. She was one of the first victims of COVID. That is what she did. The oxygen saturation, she always put it on her finger. And then the moment, because she was in quarantine, diba? In the room, the moment it will lower, she will do exercise. And so, pag check, it is again 98. So, okay ka dyan. And one, by the way, and I insert this, the PGH doctors are sharing this, that the hot tea or hot water that you drink for COVID will flush out the virus towards the stomach, okay? And that will kill the virus with the stomach acid. But the ones that lodge in the nasal, in the nose, you know, the interfolding, the concave of the nose, that is usually where they lodge. That will not be flushed out with the hot water. So what you have to do is to do steam inhalation, because 60%, 60 degrees Celsius, centigrade, the virus will already weaken. And so your immune system can already act on it. That is if your immune system is strong. Now, if your immune system is slow to action, So you have to do steam inhalation twice a day or thrice a day. Especially if you go to the market, you do your marketing yourself. When you reach home, you have to do steam inhalation, but be sure to protect your eyes, okay? So that, because the eyes is affected by the heat, okay? So you have to do steam inhalation 3 times, as much as 3 times a day, so that the virus will be weakened. And the virus usually will stay in the nose, nasopharyngeal area for 4 days. And these viruses are the ones that will find its way into the lungs and will do the inflammatory reaction. How do you increase your immune system? You have to recover your sleep. Because medical students, ang daming babasahin. During my time, 50 pages, because we were using the hard copy. 50 pages will only be discussed in 1 hour. And so in one subject. So how many pages will you be reading throughout the week? So your tendency is hindi ka matulog, okay? So during the weekend, you recover. Or during the time when you don't have exams, try to recover as much as possible. That's why there is what they call the power nap. Listen to your body. If you feel sleepy, you do power nap. 15 to 30 minutes will do. Even if you're in the classroom, but not during lectures, huh? I don't encourage. But with this, I hold you responsible. With this setup of Zoom, I cannot see you. So I treat you as responsible people. You are 100% in charge for the success of your life in the medical school, for the success of your exams, okay? To learn the art of listening, because the brain is bombarded with 80,000 thoughts per second. So it is up for you to focus. Mag-focus ka at the moment, because the lecture will not come back unless you request. Okay naman ako, okay lang with me because I don't have a family. I am single, so I have the time to be with you. But one thing, do not follow me. But you have to get married, because the singles club will become bigger, okay? At saka, you are supposed to be the ones that will populate our country. Hindi yung, yes. Kasi your kind of breed is very good. Yung mga DNA ninyo is very good. So it has to be the one that will multiply. So while in the first year, if you are not yet married, you try to look around. Your classmates, you try to find your soulmate. Wag mo akong gayahin. Because my focus is on service. Ganon yun. So you get married. so that we will have plenty of doctors. Later on, your children will also become doctors, right? Physicians. Lalo na sa CIM, 100% scholarship yung mga anak. If you are children of a faculty, if you go into medical school, that is 100% scholarship. Never mind here. Hindi na ako magano. I don't want to talk about RTR because I do not know about that. Basta sa CIM, because I come from CIM, ganun yun. 100%. That's why most of my classmates, their children are physicians. Kasi mga rare breed ang mga physicians. That's why you get married. You follow my advice, okay? Now, this is understood already. The oxygen hemoglobin dissociation curve, that during the first 1/3 of the artery, capillary, the binding of oxygen towards the hemoglobin is very fast. And towards the later part, the binding is already slow because the hemoglobin is already saturated with oxygen. Okay, so that is your oxygen hemoglobin dissociation curve. Okay, progressive increase in the percentage of hemoglobin bound with oxygen as blood PO2 increases, which is called the percent saturation of hemoglobin. Arterial blood is 97% saturated because, di ba, because it finds its way. This is admixed already with venous blood. In normal venous blood returning from the peripheral tissues, the PO2 is now only 40 millimeters of mercury, and the saturation of hemoglobin is 75%. This is still compatible with life, but very low na ito, very low. Okay, so you try to see this one. This is 20 volumes percent. Okay, when it is 100% saturated, your hemoglobin, that means 20 volumes percent of oxygen has bound to the hemoglobin. Okay, progressive increase in the percentage of hemoglobin bound with oxygen. Yeah, that is your saturation of hemoglobin. Hemoglobin saturation. Normal values. Hemoglobin is 15 grams per 100 ml of blood. 1 gram of hemoglobin can bind 1.34 ml of oxygen. So 15 grams of hemoglobin in 100 ml of blood times 1.34 is 20. That means at 100% saturation, our arterial blood carries 20 ml of oxygen per 100 ml of blood. So this is usually expressed as 20 volumes percent. You remember that this one, I showed you this one, that is 20 volumes percent. 100% saturation of your hemoglobin. Okay, you have to memorize that value. Venous blood is 75% saturated and can be expressed as 15 volumes percent. So normally, our tissues receive only 5 volumes percent of oxygen, because that is what cells utilize, the mitochondria. Only 5. But the body compensates. That's why ang dami nating cells. But this what happened? Am I still here? Nawala. Am I back? Okay na? Makita na? Can you see the screen already?
Yes po, Doc.
Okay. When you say shift to the right, this is the normal, right? Oxygen dissociation curve. Say shift to the right, there is a decreased affinity of oxygen to hemoglobin. Why is this? And this is called your Bohr effect. Bibitaw yung oxygen sa hemoglobin. Ayoko na sa'yo. Break na tayo. And ang fecal naman ng oxygen na iyan. So, increased hydrogen ions, increased CO2, increased temperature, increased 2,3 biphosphoglycerol. The left is opposite to the above. Shift to the left because there is, for example, fetal hemoglobin. The shift to the right. When there is increased hydrogen ions, increased CO2, increased temperature, increased biphosphoglycerate. In the tissues, there is shift to the right. Once the oxygen reaches the tissues, there is shift to the right because there are plenty of CO2 in the tissue cells, okay? So, give up. The oxygen will be given up by the hemoglobin. Ayaw ko na sa'yo. Dito na ako sa CO2. Huh? Very fecal siya. And this exchange is very fast. Basta, just remember, the oxygen is a fecal thing. Under normal operating conditions, the rate of oxygen usage by the cells is controlled ultimately by the rate of energy expenditure within the cells. That is by the rate at which adenosine diphosphate is formed from ATP. Because metabolism, you will spend energy, right? So where do you get your energy? From ATP, adenosine triphosphate. What is the product? Adenosine diphosphate. So this is the normal ADP resting level. Now, if the metabolism is slow, then only 1.5 normal of ADP is being produced. Whereas if the metabolism is 1/2 normal, if the metabolism is low, konti lang ADP because metabolism is slow, so energy expenditure is low. Whereas if you exercise, for example, energy expenditure is very fast. So the rate of oxygen usage is fast. Sometimes how many times normal? No? From the resting level, 3 times normal. Like that, especially with athletes, when they go into training, that's why you have to eat a lot. With these athletes, they have to eat. So the ADP produced is 1.5 times normal because of fast energy expenditure. Now, what is the action of your carbon monoxide? This is a poison, right? So carbon monoxide is responsible for shift to the left, okay? And fetal hemoglobin is shift to the left. Ayaw bibitaw, no? Would like to hold on to the oxygen. Why? Because, di ba, gamma. Instead of alpha beta chain, your fetal hemoglobin has alpha gamma chains. And it is the gamma that will hold on. So, ayaw bibitaw sa oxygen. So there is a shift to the left of the oxyhemoglobin saturation curve. Combination of carbon monoxide is a poison. This is lethal. Imagine at 0.6 millimeters of mercury level. Ano na siya? This will already interrupt this will not release the oxygen. This will combine with oxygen forever siya. Jealous. Carbon monoxide is a jealous thing. It would like to hold on. A very minimal amount. For just you try to look at this graph. 0.1, okay. 0.1, imagine gas pressure of 0.1, mayroon na siyang 20, 30 hemoglobin saturation. With 0.4, mayroon na siyang 97. There is already 97 saturation. Okay? How much more if it is 0.6? It is already lethal, 100%. So oxygen will not be released. Ayaw niya. So what do? You give oxygen, a mixture of oxygen and carbon dioxide. Let the patient inhale. Because carbon monoxide can be removed from the blood as much as 10 times faster with of oxygen and carbon dioxide. So hemoglobin has a greater affinity. Gusto niya yung carbon monoxide than oxygen. So that's why it is lethal. Okay. We'll go to the transport of carbon dioxide from the in the blood. So transport of from the tissues, from the cell, right? It will go to the interstitial space, and then it will go to the capillary. Once it finds its way inside the capillary, some 7% will dissolve in the plasma. 7%. So this is your cell, and then this is your CO2. 7% of that will dissolve. Transport of carbon dioxide in combination with hemoglobin and plasma proteins is 23%. That is your carbamino hemoglobin, this one, okay? And then transport of carbon dioxide in the form of bicarbonate ion is 70%. What happens? The CO2, ano ba yan? Bakit ba kayo ganyan? CO2 plus water inside the red blood cell will form your carbonic acid. And the carbonic acid, with the action of your carbonic anhydrase enzyme, this will be converted right away to bicarbonate and hydrogen plus hemoglobin. Your hemoglobin will separate, and your bicarbonate will find its way into the plasma. In exchange for the bicarbonate ion, chloride and water will get inside the red blood cell. So this is what you call the chloride sheath. Bicarbonate chloride carrier is the red cell membrane. So that is the chloride sheath in exchange for your bicarbonate. Your bicarbonate will go into the plasma, and then in this form, 7% dissolved, 23% carbamino hemoglobin, 50% bicarbonate ion. In this form, they are brought to the alveolar area of the lungs. Upon reaching there, ganito pa rin. Your bicarbonate ion will combine with water to form your carbonic acid, and then the CO2 is released. And this CO2 will find its way into the alveolar area because you have higher pressure in the capillaries of CO2 than in the alveolar area. So the CO2 from the blood in the capillary will diffuse into the alveolar area and then is breathed out towards the atmosphere through the nose, okay? Or sometimes through the mouth. Oxygen binding of hemoglobin promotes release of oxygen. And this is your Haldane effect. Because combination of oxygen with hemoglobin makes hemoglobin a stronger acid. So it displaces carbon dioxide from the blood and into the alveoli. So because hemoglobin is highly acidic than CO2, it has to combine with CO2 to form hemoglobin. So instead, it will displace the CO2 that is present in the carbamino form. And so the CO2 will diffuse towards the alveolar area. And acidic hemoglobin releases hydrogen. And this combines with the bicarbonate molecule to form the carbonic acid. And so this will dissociate into water and CO2. Opposite siya from the tissues, di ba? So the CO2 is released from the blood. Okay. Tapos na tayo. We're done. Just in time for lunch. It's almost 12. At, ano yan? See? We're done. Any question? Wise or otherwise? Pwede rin otherwise. Marunong ako dyan. Maski single ako. I can even teach you not to get pregnant. During our lecture in endocrine and reproduction. Ako ang mag-lecture dyan. Don't you worry. O ano? Basta
Doc,
tayo.
good morning po.
Yes. Ano pa?
Doc, may nag-ask po if how
Mag-stop ako sharing muna. Ang ano, has siya given you, nagbigay ka na sa ano, sa kanila, yung PowerPoints? Di ba may file man tayo dyan sa ano? Sa office?
This one, Doc, wala pa. Ano mo yan na din po?
Ha?
The one that you lectured, Doc.
Oo. Bigyan mo sila.
Updated man ni Doc.
Di what?
This lecture, the topics that you lectured, Doc.
Yung lahat.